Swayam Prabha. Digital India. Educated India.
Dear students, I welcome you back to the lecture series of course material of Transportation Engineering 2. In the previous lectures, we have discussed about the geometrics and then the different types of the turnouts and the crossovers. Now, from today's lecture, we will be starting with another important aspect of railway engineering, and that is signals. Signals constitute the controlling part of the movement of the rolling stock on any railway track, which is already being designed and laid, as we have seen in the case of geometrics and turnouts. Now, these signals we will be looking at the various types, and maybe we will be discussing the signals in two parts. So, in the today's part, that is part 1, we will be looking at the signals and their objectives, the types of the signals and their classifications, and then out of those classification whatever can be taken up today will be discussed. Starting with the signals and defining what the signals are. The signals are systems or devices or the means by which the trains are operated efficiently and the tracks are used to the maximum extent, maintaining the safety of the passengers, rolling stock and the staff. So, the definition itself comprises of certain things, certain objectives with which the signals are provided. What it says is that we want to have an operational efficiency and that has to be maximized. We have to maintain the safety and not the safety of the passengers, we have also to maintain the safety of the rolling stock and the staff which is operating the rolling stock. So, these are the two important things which needs consideration. One is efficiency, the one is safety. And the devices or the systems which help in attaining these things are signals. Now, the objectives of the signals, if we define a little more, then they can be that it should provide the efficient movement of trains or the rolling stock. It should ensure safety of trains which are moving on crossing tracks. It should maximize the utilization of the track. The track should not remain idle for a long period of time. It should also maintain the safety during shunting operations. This is another objective because the trains have been taken to the yards or the locomotives are going to bring some more wagons or compartments, or they have to be taken from the main track to another track, or likewise whatever operations are there. So, that safety is to be ensured along with the safety of the rolling stock which is moving on tracks or crossing different tracks, and managing the track movements during maintenance and repairs. That is another aspect which is also related with safety, that if there is any maintenance or repair work going on at any of the section of railway track, then it should help us in managing the train movements or the movements of the rolling stock. Now, we come to the classification of the signals. In the classification of signals, we have different type of basis by which the classification can be done. The one is based on the operating characteristics, another one is based on functional characteristics, then the third is based on locational characteristics, and apart from all these three, there are some signals which have some special characteristics, and on the basis of that they are classified in the fourth category. So, we will be looking at all these four categories one by one, and then within those categories whatever type of signals come or can be categorized or subcategorized will be looked at and discussed. Starting with the first classification, that is classification on the basis of operational characteristics, we found that these signals can be defined in two ways. One is that they are audible, and the other form they are visual, that is whether we are using our eyes or we are using our ears to listen or to see those signals. In the case of visual category, again they may be hand operated or they may be fixed installations. So, this is the way the signals are operated. On the basis of that, this is the type of the classification which can be provided. Now, if we look at this classification and we go into the details of these, then in the case of audible signals, most of the time the detonators are used so as to make a big noise which is audible enough to the drivers, so that they become cautious and understand that there is something hazardous which is available, or the signals have been provided ahead of them, so that they should look for them because they have come in a very close proximity of those signals. Generally, they are used during the low visibility conditions where there is a mist or fog, and therefore, it becomes very difficult for the driver to see the signal on the track. These detonators are fixed to the rails, and then as soon as the locomotive passes over that, due to the force, they detonates and makes a long big noise, and this big noise is a indicator to the driver that the signal is ahead and they should look for that signal and act accordingly. Most of the times these detonators are placed at a distance 400 meters to 500 meters before the signals. So, these type of signals, if being provided, then they are known as audible signals. Most of the time these audible signals are provided along with the fixed type of signals, so as to make the driver understand that the fixed signals are ahead of them. Then on the basis of the operating characteristics, we have the visual signals, and as we have seen that these visual signals can further be divided as the hand operated signals or the fixed signals. So, the visual signals are the one which can be seen easily, and if they are hand operated, then they are just moved by using hands, and that can be done in different ways. You must have seen at a number of times the different types of the hand operated signals. We will be looking at those a little further away. The fixed installation signals on the basis of operating characteristics are those which remains at one location only, and most of the time they are placed at the top of a post, and they may have the movable arms or they may have the colored lights by which the indications are given to the drivers, or sometimes they are also provided in the form of a disc. There can be one or there can be more than one signal on the same post. So, that type of installation, if it is there, then that comes under the category of fixed installation. Now, in the case of another classification where we are looking at the different signals, that is on the basis of functional characteristics, we found that this categorization which we were looking at now in the last stage, that is using hand or fixed, that comes under the functional condition. And then in this using hand, we have three types of signals, that is the flags, lights or the hand indication, whereas in the case of the fixed signals we have two categorizations, the stop signals and the warner signals. Now, in this case, when we are looking at the using hand condition, then here we have the flag, we have the color light and we have the hand indication, and then The flags can be, as you must have seen on the railway stations, there are certain operating staff which are provided with two types of flags. One is red in color, other one is green in color. The red, as usual, defines the stopping condition, and green again and as usual defines the priority or the movement condition, that is the allowing the movement to take place on that track. Similarly, we can have the light indicators, and in the case of light indicators it may be again the two lights indicator or a three type of light indicators, that is either it may be red and green or it may be red, yellow and green. The red and the green light has the same characteristics which are being defined in the case of the flags. The yellow is a condition which defines the caution, that is the speeds needs to be reduced because there is something due to which the whole permission of movement is not being provided on that track, and therefore, the train can move at a slower speed. Sometimes the hand indications are also used, and these hand indications are mostly used when the shunting operation is being carried out, because at the time of the shunting it is very difficult for the person who is moving behind the shunting train, that person will not be visible to the driver, or the person cannot come out and show the lights or the flags, so as the things remains visible to the driver. So, in that sense the person comes on the side and gives the indications using his hands, and that is how the driver reacts to that. So, these are generally the persons who are using these type of hand operated signals. They are the station masters, guards, gangmen, cabin men, point men, key men and similar such persons. Then further, when we come to the fixed signals, in the case of fixed signals we have stop signals and the warner signals. The stop signals are those signals which tries to define that the train has to be stopped, whereas the warner signal is a sort of condition where the caution has been defined. That means the train has to move at a slower speed, but there is no requirement to stop at all at this particular location. So, we have to look at how these two works, and we will be discussing these in the coming discussion or slides. Now, what happens here is that both the type of the signals may be having a movable arm which moves up and down, and that is how it provides the indication whether the movement is allowed on the track or not. Or the other condition is the color aspect, wherein by using the color of the signal we define whether the movement is allowed, or the movement is allowed with some caution, or the movement is not at all allowed on this track. Therefore, this indicates the stop condition or the caution condition respectively, as already told, and these are operated using electric current or wires or keys. So, these are the things which are used so as to operate these two type of signals, may be in the movable arm condition or in the color aspect condition. So, in the color aspect generally it is an electric current condition which is used, whereas in the movable arm condition it is wires and keys which are used so as to move those arms. Then further, when we come to the fixed signals and we are discussing both type of signals, then these both signals can be provided using either movable or current lights, and movable arm signals are known as semaphore signals. That is a specific name which is given to those signals which are provided with movable arms, whereas those signals which are provided with the colored lights, they are termed as color aspect signal. So, this is the distinction between the two categories of signals which are using either the movable arm or the colored light. Now, we look at the semaphore stop signal. In the case of semaphore stop signal, as already being defined that it is having the movable arm. So, what we found is that there are number of things which are provided on this semaphore stop signals. It has large number of components. The components are the movable arm, the spectacle holding two color glasses, lamp for night indication, crank rod, cam, lever and counterweights working as a one complete assembly, signal post, chains and pulleys so as to operate the movable arms, and wire to the cabin from where it is operated. So, these are the things which are provided in the case of a semaphore stop signal, and that constitute a signal. Now, we look at this diagram. This diagram tries to define what is semaphore stop signal and how it looks like. In this case, what we can see is that there is a big post which is located like this. This is a big post which is located at the ground level GL. At the top of this one, at some distance, we are providing this arm. This is an arm which is pivoted at this location here. So, we have the spindle here with respect to which it will go up or go down. Now, this movable arm, this is of same rectangular size and it is 25 to 35 centimeter in this width, and this movable arm is provided at a height of 7.5 meters from the ground level. So, this is the center of this movable arm. So, the center of this movable arm is at a height of 7.5 meters. This movable arm is provided with a band, and this band is white in color, whereas the rest of the color of this movable arm, that is red. So, therefore, there is a white band on the red background, that is what is the color combination of this movable arm. Then on this side of this movable arm, we are providing two glasses, and the glasses are red and green in color, and these are provided within this section which is known as a spectacle. At the back of this spectacle, a lamp is provided. So, this is a lamp which is being shown at the back of this spectacle. Now, as this arm moves, accordingly we will be having a red light or a green light. This spindle is connected to the cam at the bottom at this location, and this cam is having a total combination of lever, balancing weights, etc., which are provided here. So, we have the weight at this location, we have the balancing lever here, and if it moves up and down accordingly, this crank rod will move, which is making a connectivity between the cam and the spindle. So, we have this crank rod, and this cam is connected by using a chain which passes through the pulley, and it goes up to this, and then from there the wire goes to the cabin. So, that is how the total assembly of any semaphore stop signal is being provided. Now, on the basis of whether this wire is being stretched or the tension is being given to this wire, then this will operate this chain, and this chain will further operate the cam, and with this help it will go up and this will come down, and that is how this semaphore stop signal works. So, in this case of a semaphore stop signal, what we can observe is that the movable arm can remain maybe in the horizontal direction as it is being shown in this case, or it may go down at some angle, or it may go up at some angle. The angles which can by which it can go down or by which it can go up, it may be 45 degrees or 60 degrees, or in some cases it may be vertically upward also. So, depending on the condition which we are interested in defining, this movable arm will be working. So, if we look at this semaphore stop signal, this is another diagram where we are trying to show the two conditions. The first condition where it is being shown as a horizontal arm, that signal indication shows is stop, and when it is a stop, then the lamp will be oriented behind the red light. So, the red light will also be seen during the night as well as the day operation. Now, if we look at the another condition where now it is a proceed condition where the arm is going down, it is being stressed in such a way that the arm goes down, then in that condition the green glass will come in the front of the lamp and it will get illuminated, and that is how we will be seeing the green light. So, that is the indication of proceed. So, 2LQ it is a second lower quadrant with the multiple color aspect lower quadrant signal. So, here what we have seen is that there is one position which is termed as on position. This is what is being depicted here in the first diagram. This on position defines that the arm remains horizontal, and when the arm is horizontal, then it indicates a stop condition or a danger condition. So, that is a way it is defining the stopping of vehicle, and during night time the red light will be seen. So, if it is not possible to see this arm, then with the help of the red light the driver can understand that it is a stop condition and therefore, the vehicle has to be stopped. This is the natural condition of the semaphore stop signal. In the normal conditions, the semaphore stop signals will remain in a on position, that is the arm will be horizontal or the light will be red in color. Similarly, we can look at another condition signal indication, that is off position signal indication, where the arm is lowered at an angle of 45 or 60 degrees, and during the night operation it will be visible with the help of the green light which will be seen on the side of this movable arm. So, that is how we have another position which is termed as off position and which allows the movement of the rolling stock on the railway track. So, these are the two signal indications in the case of the semaphore stop signals, the on position and the off position. Further, in the normal position it always shows a stop, that is the arm remains horizontal, or what we can say is that it is a on position of the semaphore signal. If there is any failure of the signal, or if suppose there is no light, then in that case it turns to the stop condition. So, that is another feature which is being installed in it, because if there is any problem with the operation of the signals, then the signals should switch to the off position, that is to the stop position, that is on position normally. The red colored side of arm remains towards the driver. What we have seen is that there is a white band on the movable arm with the red background. Now, this side will remain towards the driver, but how we are going to identify whether this is a front side or the back side is defined by the color of this movable arm. At the back, this is white in color with a black band in between at the same location where the white band is provided on the front side. So, it means if the driver is looking at a signal and he sees the white color of the movable arm with a black band, then it means that signal is not pertaining to his operation of the rolling stock or the train on the track, and he has to look for some other signal. Whereas, if the driver looks and finds that the color of that movable arm is red with a white band, then it means it is related to his track and he has to follow the instructions given by that. These are generally placed on the left hand side of the direction of the movement. So, that is another guideline which is provided for the provision of these type of signals. Now, in this case of semaphore stop signals, we have one category of signal which is termed as lower quadrant signal. This lower quadrant signal uses the fourth quadrant of the four directions in which the overall space can be divided. And it works with only two aspects, namely horizontal and inclined downwards, that is on condition, off condition, red or green position. Whereas there is another category where it is termed as the upper quadrant signal, and just opposite to the lower quadrant signal, and most of the time it is used in those locations where there is a high density on the roots. How it works is that it has three aspects instead of two aspects as being used so far in the previous cases, and they are horizontal, which means it is an on position and it indicates the red light, means now the vehicle has to be stopped. It may have inclined position instead of a downward inclined position. Now, in this case of an upper quadrant signal, it is 45° upward and it indicates caution, or in the color aspect system it will be yellow in color. Then there is a third condition which is vertically upright. This vertically upright means this is off condition and it means it is green, and the train is allowed to move with the same speed which with it is coming. In the case of lower quadrant, most of the time we have not provided this vertically downward condition because it becomes just synonymous to the rail post, and therefore, at times the driver may find it difficult to understand that this is a problem in this case, and that is driver will not be knowing where the downward arm of the signal is there, and that is why in the case of the high density routes it becomes more efficient as compared to the lower quadrant signal. This is a multi aspect upper quadrant signal being shown, that is MAUQ, multi aspect upper quadrant. So, here we have the horizontal condition, we have the inclined upward condition at 45° and the vertically upward condition. All the three have been shown along with the three light conditions, that is in first case where this is on position it is a stop, and that is why this is red in color. In the second case it is caution, and that is why it is yellow in color, and in the third case it is proceed, and that is why it is a off situation and it is green in color. So, that is how this aspect signal will work. Now, instead of this one, if we have the lower aspect signal and we assume that this remains vertically downwards, then it will become very difficult for the driver to see the position of the arm with respect to the post, and that is why this is not provided in this form in the lower quadrant signal system. Now, we are looking at some more semaphore type of the stop signals in this diagram. These are basically the variants of the semaphore stop signals. In this case, the first one is defining the goods yards condition, that is, it is the stop signal which controls the approaches provided to the goods yards. So, in that case, along with this white band, a circle is being provided like this. So, this is how it is defined. Whereas, if the same location where the white band is provided, a D is also provided like this, then it means it is defining the stop signal which is controlling approaches to docks. Similarly, at times there may be a big X or a crossing wires being provided alongside this one, and it indicates that this signal is no more in use, it is decommissioned and the driver has not to follow this particular signal. Similarly, we have another variants also available. Some of the important variants are again being shown here. This we have already seen, that is in a stop condition where the red background is provided with a white band. This is the circular condition. The circular will be having certain thickness which is black in color, and this is for goods signals. In the case of locomotive signal, L is provided just in front of the white band. So, this L is overlapping this white band and this L defines locomotive signal. So, locomotives has to follow this one. Then there may be a calling on signal, where in the case of calling on signal we have the white background with a red band, and that is how it is identified that this is calling on signal. Then there are some automatic signals where what we observe is that this is V in shape, and then we have a band which is again V, and here this band is white in color and it is provided with the background as red. So, what we have seen is about the semaphore signals, where we are provided with the movable arms. Now, we will be looking at the another category of signals, which is the fixed signal in nature, but they are provided with color aspect conditions, that is they are provided with the lights which are of different colors, and still they work as a stop signal. So, in this case the semaphore signals are replaced, that is the movable arms are replaced by the color aspect signals which are provided on electrified tracks. Most of the time this high intensity color beam is focused at the level of the eye of the driver, and this high intensity color light is so intense, being having the wavelength etcetera in such a way that it is even visible during the daytime as well as it is also visible during the night. So, it provides the indication both during the day as well as during the night. And the normal position of color aspect signal is off, that is green, indicating proceed. So, this is just the opposite to what is being given by the semaphore type of signals or movable arm signals. In the case of movable arm signals, the on position was defining the normal condition, where it was defining the stop or the danger ahead condition. Whereas, in the case of this color aspect signals, the normal position is off, that is it is defined in terms of a green color indicating proceed. So, unless until there is a problem, that will not be turned to a red light, or if it is being occupied, then only it will be turned to the red light, otherwise you are allowed all the time to move on the track. So, now as we are discussing about this color aspect stop signal, what we observe is that as soon as the track is occupied, then this color of the color aspect signal will turn from green to red, and this indicates the on position, and which is defining the stop or danger. That is, now no other train or the rolling stock is allowed to take this position or occupy this track, unless until it is being made open again, that is it is not being occupied, the color of the signal will not turn back to green. In the case there is a failure, then it will always show the stop condition, that is the on condition will come by itself, that is a default condition of any such signal, because otherwise if it remains in a green condition, that is it allows the traffic to move on and there is a failure, then there are chances that accidents will take place. Most of the time these color aspect stop signals are used for the locations or the sections where the traffic is very heavy, the volume is very high, or they are also used for the urban and suburban tracks being provided in cities where the local trains or metros etcetera are plying. Now, this is one diagram which tries to show the fixed signal, which is a color aspect stop signal. This is a 3 color aspect signal. In this 3 color aspect signal, it is being provided with a 3 colors condition, that is we have the stop condition where the red color is being shown, we have the proceed condition where the green color has been shown, and there is a third condition in between. Sometimes we will found that the signals are just having 2 colors and sometimes they have 3 colors. In that condition, the central color will be yellow in color or amber in color, and that defines the caution. That means, if it is there, the train has to move at a restricted speed till the green color is being provided or the green color comes on the signal. Now, in this case another diagram which we can see, this is a 2 color aspect signal, where as we have seen in the previous case only two things have been defined. One is either it is a stop condition shown by the red light, or it is a proceed condition shown by a green light. So, it means two lights are only being given in this one. So, we have a 2 color aspect signal, we have seen a 3 color aspect signal. Similarly, we can also have 4 color aspect signal too. We will be looking at that one. In the case of the 2 color aspect signal, it shows either stop or danger, that is being shown by a red light, and the proceed being shown by a green light, or there is a warning which is shown by yellow and proceed by green. This is the two combinations which can be there, either it is in the form of red and green, or it may be in the form of yellow and green. Means whatever is the condition, the number of colors which will be there on that signal post will remain 2. So, that is how it is defining. So, either it will define a stop or danger condition along with proceed, or it will define a warning condition along with proceed. Then in the case of a 3 color aspect signal, it uses 3 aspect, that is the stop condition, where it is come as wrong here, it is not green, you read it as red here, because this is a stop condition. So, it is red in color, and then it defines the danger, means the train is not allowed to move on this track because it is already being occupied by some other train, or there may be a caution condition where it is going to be defined by yellow in color, and then there is a proceed condition which is defined by green color of the signal. That means now the train can move with full speed. This 3 color aspect signal nowadays is more common as compared to the 2 color aspect signal which has been used previously for all those sections where the traffic was not very heavy. But now as the traffic is increasing day by day, therefore, what is being observed is that there is a need to provide the 3 color aspect signal which are mostly in use on all the locations. Now, within this category, as I have defined previously, that there can be a 4 color aspect signal also. Now, in the case of 4 color aspect signal, we will be having one color as red, another as green, and then we have 2 lights which are devoted to yellow, and these yellows are termed as yellow color and double yellow color. So, this is what is the sequence, the red, yellow, double yellow and green. Red as usual means a stop or danger position, that is it is in the case of this color aspect signals, it is on position with defining stopping. The yellow means warning, that is you can pass the signal cautiously and be prepared to stop at the next signal unless you are being given a green indication. So, this is what is the meaning of the first yellow, that is it is a simple caution that you have to move the signal slowly. Whereas, we have 2 more options in this one, that is there is a second yellow or a double yellow condition, and this double yellow condition means that you can pass the signal at full speed, but be prepared to pass the next signal at cautious speed. So, that is the difference between the two. In the first case, it was that you can pass this signal cautiously, and then you have to look at whether you have to stop at the next signal, but when this double yellow is there, then it means that you can pass with full speed here, and you just check out for the cautious condition which can be there at the next signal. Green as usual again means that the signal can be passed at complete full speed, and it is most likely that the next signal will also be green in color, allowing the train to move on the next section. Now, this is how it looks like, as we see that this is a 4 color aspect signal. In the case of 4 color aspect signal, the sequencing remains like this, that this is red, this is yellow, and this is green, and this is another yellow, and if we have the two yellows working together, then that is a double yellow condition. So, we have a red means we have a stop condition where the train has to stop completely. This a yellow condition means the train has to move with caution and has to look whether it is to be stopped and the next signal. This is a simple attention that you are moving at a high speed, and most likely you are going to get a green color on the another one also, but just pay attention that you have another signal very near. And proceed means that there is a green color, and therefore, it is defining that the train is allowed to move at the full speed, and at the next signal also you probably will be allowed to move again with the next full speed. So, that is how these four color aspect signals works, and it has an advantage in the form that it tries to indicate the driver about the condition which may be prevalent on the next section or the section from where the another set of signals will be working. Now, we come to the another type of a fixed signal, that is termed as Warner signal. This Warner signal, as we have seen, this defines the caution of the train movement, and in this case it is provided there is some difference in the movable arm which is provided in the Warner signal, and this difference is that it is provided with V notch at the free end, and with respect to this V notch a V band is provided. That is the difference between the semaphore signal and this one. In the case of semaphore signal, what we have seen is it was a rectangular arm, and there was no notch being provided, and therefore, the band which was provided in white in color was also rectangular in section. But here at the end it is V, and similarly the band is also V. Then the another difference which comes is that in the case of semaphore signal, as we have seen, it was red background with white band, whereas in the Warner signal it is yellow background with a white band. So, that is another difference between the Warner signal and the semaphore signal. Then this type of a Warner signal which is trying to define caution can be placed either separately on a post, or it can also be placed in combination with a stop semaphore signal. So, these are the ways by which we can do it. It depends what is the requirement where the thing is to be provided, and accordingly we can either economize or provide the things. Now, and the same another thing is that if it is provided at all with the stop semaphore signal on the same signal post, then it is to be placed at a distance of around 1.7 to 2.1 meters below the semaphore signal, that is below the center line of the semaphore signal movable arm. At this much distance we can provide a Warner signal. It indicates yellow color light and the green color light instead of a red color light and a green color light being given out of a semaphore signal, because this is a caution signal. It is not defining the stopping of the vehicles, it is defining the restriction on the movement of the vehicle in terms of its speed. That is why it is yellow in color or green in color. Now, how the indications works, that is another important aspect which needs to be understood, and this is to be seen in terms of whether the Warner signal is provided on a individual signal post or it is being provided in combination with the semaphore signal. Now, here first of all we are discussing about a condition where the Warner signal is being installed separately on a post, and therefore, in this condition we have two conditions. One is that the Warner arm is horizontal, and it means that it is defining the on position which defines the stop condition, or the Warner arm is inclined and it is an off position for it, and it means it indicates that the proceeding is being allowed at this signal. As far as the lights are concerned, that is the first two cases were been defined in terms of the movement of the movable arms, whereas in the case of the light, if the light is yellow, then it means that it is an on position or the stop position, whereas if the light is green, then it means the off position is there, that is the train is allowed to proceed with full speed. Now, in this diagram we are looking at one of the Warner signal as being defined. As Warner signals are provided with the yellow background and the band which is again as a V notch, and at the end it is having a V notch. So, we can see that this is a V notch being provided here as well as here, and it has two colored glasses as in the case of the semaphore signals, and this one glass is yellow in color and other glass is green in color, and depending on its movement we will be having the movement of these glasses with respect to lamp, and we will be having the indication either yellow or green in color defining the caution or the proceed respectively. So, that is how these multicolor conditions or lower aspect quadrant signals works. Further, this is a multi aspect upper quadrant Warner signal, where it is working in the same way as we have seen previously in the case of semaphore signal, but some difference is there in terms of the not only the type of the movable arm which we are using, but in this case also where here this is yellow in color, and this yellow in color means in the center not caution, but attention here. That means it is the train is allowed to move with the speed, and the only thing is that the driver has to be cautious enough to look at the another signal and its definition. Whereas, in the case of vertically upward condition, where it is defined in terms of a green light, then it shows proceed. So, that is some difference in the case of the multi aspect upper quadrant signal system in the Warner condition as compared to the semaphore type of the signals. Then further, if we look at this Warner signal, where the Warner signals are provided in combination with the stop semaphore signals, that means they are being located at some distance below the movable arm of the semaphore signal, as we have seen this distance is 1.7 to 2.1 meters. So, here number of conditions may happen depending on the position of the movable arms of Warner signal and the semaphore signal together. Now, in combination with the stop semaphore signal, what may happen is that the both arms are horizontal, that is the semaphore signal movable arm and the Warner signal movable arm both are horizontal, and it means this is an on position and it defines a stop, that is neither approaching nor block section is clear. Means we have the two sections, one is the section which the train is approaching just ahead of the signal which is to be crossed, another one is the next section which it will be taking up. So, in that sense, if both the arms are horizontal, it means both the things, that is the approaching section and the other section big block section, both are occupied and they are not clear for movement of this train. Whereas, if the semaphore arm is lowered, it is made down and the Warner arms remains horizontal, then it indicates that the train can proceed, but with caution for the approaching section which is clear, but the block section may not be still be clear. So, there is some restriction in the speed in this case, that is the approaching section is clear, the train can move in, but then it may probably has to stop in the next signal because it was not clear. In case both the arms, that is the arm of the Warner signal and the stop semaphore signal both are lowered, then this is defined as the off position, and it is a condition where the train is allowed to proceed with full speed and the section ahead as well as the block section both are assumed to be clear. So, that is why the train can move with a complete speed in this case. Further, there is a condition where the semaphore and the warner both signals are having light yellow colors. This is in terms of the light instead of the movable arms, then it means this is an on position and the stop condition will be there, that is neither approaching nor block section is clear. That is the first condition as we have seen in the previous one, where both the arms were horizontal. Then semaphore light is green and the warner light is red or it is yellow, then it means we can proceed with caution. The approaching section is clear, but the block section is not clear. And the semaphore and warner, if both the lights are green, then it means it is an off position, that is it allows the proceeding, and the station and the block sections are both clear. That is a way how we define the combinations of different conditions as being shown here in this diagram also. So, we have the warner signals, the fixed signals. This is the first condition where we have the two movable arms. This is for semaphore signal and this is V notch arm which is for warner signal. This is yellow in color, this is red in color, and then if both are horizontal, it is means it is a stop condition, whereas if this semaphore signal is lowered, that is it is showing a green light, whereas this warner is horizontal showing the yellow light, then it is a cautious condition, means you can move with caution, but the next section is going to be occupied. And then there is a third condition where both the arms are downward, and that means both are showing green light, and in this condition we can move with the same speed as we are moving, and another section is also going to be on, that is we can move on that section too. So, this is a case when we are having a combination of the warner with the semaphore signal on the same signal post, but there are conditions where this is provided in this form, that is this is a green light at the top and there is a lone warner which is provided like this, and then it tries to define caution. If it goes down, then it defines the proceed. So, that is a combination with the stop of semaphore type of signals. So, this is what we have discussed. We have tried to see at the two types of classifications of the signals, that is one which was based on the operational characteristics and the another which was based on the functional characteristics. In the case of operational characteristics, we have seen that how the two signals are operated. One maybe it is in the form of detonators, that is, and maybe in the form of the signals which are made to be visible to be looked at by eye. In the case of the function, we have the hand operated signals and the fixed signals, and in the case of hand operated signals, we have seen that it may be in the form of a flag, it may be in the form of a light, or it may be in the form of the hand indication. Similarly, in the case of fixed signal, what we have seen is that the signals can be divided into two parts, the stop category of signals which are termed as semaphore signals, and the warner category of signals, that is the signals which tries to caution. So, in the case of this fixed category, we have seen that we have the warner signals and we have the semaphore type of stop signals, and then these two type of signals can also be used in combination with each other at the locations where there is a heavy density, a heavy traffic which is moving. So, this is the two type of categories of the classifications of the signals. The two other categories of the or the classifications of the signals, that is based on their locational characteristics and based on their spatial characteristics, will be discussed in the coming lecture. Till then, we stop at this point, and I say thank you to you and goodbye.
Thank you.